This chip flip activity is a coin flipping game to demonstrate random variables and expected values. You may choose to have some colored coins. We used some bicolored coins. One side was yellow and one was red. You could also do the same experiment using a coin, like a nickel or a penny or something. And instead of yellow and red, you could use head and tail. So that would work out as well. What we're going to do is draw a tree diagram that will show all of the possible sample points for this carnival game. At a carnival, you pay $2 to play a chip flipping game with 3 fair chips. On each chip, one side is red and the other side is yellow. You flip the chips at one time and you will win $1 for every red chip that appears on top. Are your expected earnings equal to the cost to play? So the first item says, in this game, the random variable of interest counts the number of red chips that show. What is the sample space for the values of this random variable? So if you have your 3 coins, what you're really looking for is how many end up red. So think about how those coins could land. If one side is yellow and one side is red, it could be that none of the coins end up on the red side, or one coin lands on red, 2 coins land on red, or all 3 coins could land on the red side. So this is our sample space. For part 2, we're going to draw a tree diagram that will show the sample points. So these are going to be all of the possible outcomes. So let's construct our tree diagram. If this is my first coin, the options are red or yellow. So I'll label R for red and Y for yellow. Now think about the second coin. Coming off of this branch, again, I could have another red, or the coin could end up on yellow. Following this branch, if your first toss was yellow, you could still end up with red or yellow. And the third coin now gives us a third branch off of each one of these outcomes. So I could either have red or yellow again. So at the end of each branch will give you the sample points. Starting with the first coin, I could have had a red, red, red. So I'm going to write those down in this space provided for number 3 to list these sample points. So that was red, red, and red. Next, we could start with the first coin and go to red, red, and then yellow. The next branch would show red, yellow, red. And then we could have red, yellow, yellow. Now if our first coin is yellow, we could have yellow, red, red. We could have had yellow, red, yellow. We could have had yellow, yellow, red. Or we could have had yellow, yellow, and yellow. So these are all the possible sample points. Here we have a table constructed of the number of reds, so we already knew that the sample space consisted of 0, 1, 2, or 3 possible reds. Now the frequency is filled in, so if we have 0 reds, the only sample point that shows 0 reds would be the yellow, yellow, yellow. So with a frequency of 1, we're dividing that by 8 because we have 8 different sample points. So 1 divided by 8 gives us 0.125. And x times our probability of x gives us 0 because 0 reds times the probability would give us 0. Next, if we had 1 red coin, we're going to go back to the sample points here and see how many of those have 1 red only. So there's 1 red, 1 red, 1 red. So 3 of the 8. So 3 divided by 8 gives us 0.375. So our x times probability of x would be 1 multiplied by 0.375. So that would be 0.375. Next, we're looking for 2 reds. So we're going back to the sample points to find 2 reds. 1, 2, 3, so only 3. 3 divided by 8 would be our same calculation as the previous one, 0.375. And now x times the probability of x would be 2 times 0.375, and that gives us 0.750. And finally, we're looking for 3 reds. So we have one combination only that involves 3 red chips. So there's only one. And our probability then is 1 divided by 8, or 0.125. So x times probability of x would be 3 times 0.125, and that's 0.375. To calculate the expected value, mu is equal to E of x. And that means we're looking for the sum of our x times the probability of x. So we need to go back to this last column and find the sum, which is 1.5. So this represents $1.50. So how does $1.50 fit into this carnival game? For question 6, we're looking at our expected earnings and comparing that with the cost of the game. So the expected earnings are $1.50. The cost of the game was $2. So is our expected earning less than, equal to, or more than the cost of the game? So $1.50 is definitely less than $2. So if your expected earnings are only $1.50 and the cost of the game is $2, that means you've lost 50 cents playing the game.